Okay, I just want to give you a short explanation on what I got going on here. This is the test setup that I'm using to test the repetitive capability of these various sealed pouches. Over here we have the roll drive. This is what I'm using to simulate a player piano music roll. I have this test roll that was manufactured for me by Ed Gaida, and I'll just zoom in on this label here. This is a pouch test roll, and I'm going to show you how that works. And you'll see here in a minute. Right now I've got it set at 110. This is adjustable. I've calibrated it so that I can, and this is what this does. All it does is play repetitive notes. First, considering that I want to test the repetitive capability of these pouches, this is really all that I need. So while this thing is a little noisy, it certainly gets the job done. And I've got a control over here that can rewind it when it's 15 feet long, so it gives me plenty of time. It's 15 feet long, so it gives me plenty of time to go ahead and do the tests that I'm going to do. I do the tests initially at 50, 80, and 110. I have here these very sensitive vacuum sense switches. I have two of them, one there and one there, and they're connected right up to the pouch. One of them is connected up to the pouch, as you can see there. The other one, this one right here, is connected to the bellow, which I've got closed. Let me back out here. Which I've got closed at this time. I found that having the bellow open really affected the measurement, because what I want to find out is how long there is vacuum inside the bellow as coming from the valve. In other words, it stands to reason that once the valve turns off, there's still vacuum escaping from the bellow back out through the exhaust port, and so there's actually still vacuum in there. And because of the fact that these switches are so sensitive, it measures that length of time that the vacuum is still inside the bellow. So I'm trying to get that out of the equation in terms of testing, so I've collapsed it all the way. Right here we have the manometer, and right now it's set just almost exactly 5 inches. This is operating off of a bleeding system. This is a bleed. Okay, so the vacuum level is very, very stable under all operating loads. What else? And we've got the voltage. The voltage used to operate the switches is provided by this power supply, and that's what's connected to these. And then over here we have the dual sweep oscilloscope, which is going to actually be measuring the length of time that the signal is coming from the tracker bar and the amount of time that the vacuum is in the bellow. Also, right here we have 10 feet, actually there's 10 feet of tracker bar tubing between the tracker bar and this point right here. This is where the tracker bar tubing connects to the pouch. What I'm trying to do there is simulate a long run like you would find in a reproducing player piano. Here again, the length of the run, the length of the tracker bar tubing certainly does affect the strength of the signal that arrives at the valve, and so we're trying to create a very difficult scenario for the valve to come on and off. Trying to make it very difficult. I found that with very short runs of tubing under normal operating loads of 5 to 7 inches of vacuum, it really didn't matter what sealant you used on the pouches. They all worked exceptionally well. None of them failed. None of them failed to repeat even at the highest repetition speeds. I mean, it really didn't matter whether you use rubber cement, hydrophane, Pell Seal, Dow Corning 3140, Dow Corning 111, or diluted PVCE glue. It just didn't matter. They all worked at nominal vacuum levels that you would find in a player piano. So in terms of determining which one is best, you know, you have to create very difficult scenarios to determine which one actually performs better. Because, like I say, under normal situations, they all get the job done. So it doesn't matter which one you use, and they're all going to last. Probably forever. So, like I say, in terms of testing, you have to actually go to extreme circumstances, like operating at below 5 inches of vacuum on a 10-foot run of tracker bar tubing before you begin to and it also at very, very high repetition rates before you begin to actually notice any difference in the performance of the various sealants. So that's the setup.